In the last video, we talked about Bronsted-Lowry acids and bases and drew out a reaction using a mechanism. How do we explain Lewis acids and bases? Remember that Lewis acids are electron pair acceptors, while Lewis bases are electron pair donors. A quick way to figure out if a species is one of the two is to draw out a Lewis structure. A Lewis acid should not have a lone pair on the central atom, while a Lewis base should. For example, in a reaction between aluminum trichloride and ammonia, aluminum trichloride acts as the acid, since it has no pairs on the central atom, and ammonia acts as the base, since it has a lone pair on the central atom. The lone pair from ammonia can reach out to the aluminum and grab it. If you remember that a covalent bond consists of two shared electrons, it'll make sense that a covalent bond forms from one of ammonia's lone pairs, since it is two electrons. The only thing left for us to show are formal charges. Aluminum now has a formal charge of -1, and nitrogen now has a formal charge of +1. Notice that on the left side the net charge was 0, while on the products the formal charge is still 0. Now is a good time to introduce two new terms, electrophiles and nucleophiles. Electrophile simply means electron loving, and nucleophile means nucleus loving. Since electrons are negatively charged, we can determine that an electrophile will be positively charged. Since a nucleus is positively charged, we can determine that a nucleophile will be negatively charged. Let's use carbon as an example. If we take the two forms of carbon that we know will have a formal charge, we can determine that since carbon on the left has a negative charge, it'll be attracted to a positive charge. Therefore, it's a nucleophile. Since the carbon on the right has a positive charge, it'll be attracted to a negative charge. Therefore, it's an electrophile. Electrophiles are electron deficient and can act as Lewis acid. Nucleophiles are electron rich and can act as Lewis bases. The two types of carbon we had before have unique names that will be extremely useful for future reference. A positively charged carbon is called a carbocation, and a negatively charged carbon is called a carbanion. A carbocation can act as a Lewis acid, and a carbanion can act as a Lewis base. In this video, we talked about Lewis acids and bases in more detail, describing that reaction mechanistically. We also defined electrophiles, nucleophiles, carbocations, and carbanions. In the next video, we will talk about acid-base strength.